Hi everyone, in this video I'm going to be talking about atoms and molecules. Forget about chemistry for a second. Just answer me this. What do you see on your screen? A school, an aeroplane, people, car, buildings. All these are valid answers. But is there a way that you all give the same answer to this question? Well, yes. Chemistry has given us a word that will incorporate everything that you see on your screen right now. And that word is nothing but matter. So yes, everything that has mass and occupies space is called matter. Well, there goes the definition of matter, but to understand it, anything and everything which you see around you, even if you don't see it, the air around you, you don't see it, right? But it is matter because it has mass and occupies space. So for the curious minds long back, let's call them scientists, it was very important to ask this one question: what is matter around us made up of, or what comprises the matter around us? Such people used to give theories and philosophies to explain what could be the answer. So the thing with theories is that they could be true or not because they are not based on any scientific experiments, but are just some ideas which develop in curious minds to explain reality. One such theory said that any element, gold per se, if broken repeatedly into smaller and smaller pieces, we will reach a stage which is not any further divisible. A great Indian philosopher, Maharishi Kanad, called this stage Parmanu, and another Greek philosopher, Democritus, called this stage our very own atom. Remember, these were just theories because they were not based on any scientific evidence. On the same lines, having the same idea, an English chemist, John Dalton, gave his theory, which was called the Dalton's atomic theory, and he spoke about the existence of an indivisible species in matter and called it atom, just like Democritus and Maharishi Kanad. He gave many more postulates which make perfect sense even today, but it was later found out that atom actually is divisible into subatomic particles called electrons, protons and neutrons, about which we will be studying the next unit. But this led to the failure of the Dalton's atomic theory. Now let's discuss one of the most important questions: what is an atom exactly? So as already discussed, if we keep on dividing any element, let's say gold, silver or sodium or any other element, if we keep on dividing it repeatedly, we will reach a point where it is not further divisible, and that point is called an atom. All these atoms of different elements differ from each other based on various properties like its mass and the number of subatomic particles that it has, but we will talk about that another day. Now that we know what an atom is, let's try to understand how small an atom is. Atom is unimaginably small. If I tell you to imagine small things, some of you might imagine a grain of rice, maybe thickness of hair. But to understand how small an atom is, we will do a comparative study here. Let's talk about our planet Earth. It's huge, with a radius of about 6,371 kilometers, which translates to these many meters. Since it's a comparative study, we will be comparing all the radiuses in meters to get a clearer picture. Moving on to a smaller level, let's talk about a tennis ball, which has its radius in order of few centimeters, which translates to these many meters. Going to an even smaller level, if I talk about the grains of salt, this is having its radius in the order of few millimeters, which is much smaller than a meter. If we go to an even smaller level, if I talk about bacteria, they have their radius in order of few micrometers, which is 1/1,000,000th of a meter. To go even smaller, if I talk about the radius of a DNA, it's about 2 nanometers, which is about 1/1000,000th of a meter. Now we reach the stage of atoms, which have their radius in the order of few angstroms, which is 10 billionth of a meter. All in all, atoms are small, very small, unimaginably small. The model of an atom which you see on your screen right now is something which we will discuss in the next chapter. So we have spoken about elements like gold, silver and sodium and talked about their atoms in the last few minutes, but we have a total of 180 known elements. Now let's imagine something. Let's imagine that you're a scientist working on an element hydrogen and you have discovered something out of this world, and you take your discovery to a university in Germany, and when you start talking about your discovery about hydrogen, people there are unable to understand even a word because hydrogen is not called hydrogen in their language. Quite a bad day for you, isn't it? So what we need right now to avoid such confusions is common symbols for every element. so that they can not only be understood locally but can be understood worldwide. Dalton again was the first one to understand this issue, and he came up with various symbols of various elements. The problem with these symbols were that they were very difficult to remember and draw. The IUPAC, or International Union of Pure and Applied Chemistry, which is an international organization which represents chemists and chemistry, came up with the solution. They suggested that every atom will have a symbol which is normally the first two letters of the name of the element. For example, aluminium is Al, argon is Ar, barium is Ba, which is quite easy to remember, right? But if you look closely, you will realize that this does not match in all these names. For example, in sodium, the initials are SO, hence the symbol should be SO, but the symbol is actually Na. That is because in Latin, the name of sodium is natrium and the initial of natrium has been used here. The same is the case of silver, where it is actually argentinium in Latin. Now these 118 elements are arranged in well-defined order and are classified into groups, periods and blocks. This arrangement of various elements is called periodic table, and it is called the periodic table because the classification is based on the periodicity or repeating property of various elements in them. Now in chemistry we have reactions or chemical reactions in which reactants convert to products. Any chemical reaction or combination are governed by basic laws, and those are called laws of chemical combination. Two such laws will be discussed in the course of this video. The first one is the law of conservation of mass. The definition of law of conservation of mass was that mass can neither be created nor be destroyed. This was given by Antoine Lavoisier. To understand what this law states, let's talk about an example. Let's say you have a box and you add two balls in the box. Let's say you close the box and just move away. When you come back and you open the box again, how many balls would you expect to come out? Of course, two balls would come out, right? The same thing is the law of conservation of mass. However number of atoms and molecules participate in the reaction, the same number of atoms and molecules will be made out as products also. For example, here we have 4 atoms of hydrogen, 1 atom of carbon and 4 atoms of oxygen taking part in the reaction, and they are the reactants. As products, we have rearranged but only 4 atoms of oxygen, 1 atom of carbon and 4 atoms of hydrogen made. This is the law of conservation of mass. The second law is the law of definite proportions. This law states that a given compound always contains exactly the same proportion of elements by weight. This was given by Joseph Proust. Again, let's understand with an example. Let's say we talk about water. Water from your kitchen and water from your, let's say, school. These two are 2 different glasses of water derived from 2 different sources, but both are going to have 1 atom of oxygen and 2 atoms of hydrogen always. So irrespective of the source of water, no matter this water is from your house, my house, Germany, Australia, whatever, no matter what is the source of the water, this will always be having 1 atom of oxygen and 2 atoms of hydrogen. That is, oxygen to hydrogen ratio is always going to be 1:2, no matter what the source of the water is. This is the law of definite proportions. And that's a wrap for today. Now you can visit EduRev, read the notes and practice the test to understand this topic even better. Thank you so much for watching.